The answer to number 11 on the first topic review, it was a composition question, and it was 8 was the answer. And it was a little odd, this composition question, because it used charts or tables to get the answers. I'm just going to show you, looking at the original question here. Sorry about this bad video. It wants you to find g of f of x, and we always work compositions backwards. I'm sorry, g of f of 3. So we're going to go to the f table right here. And if you're doing f of 3, x is 3. So out comes a 5. So now you're really going to put the 5 into g, and out it's going to come an 8. That's how it does that. I just did it on paper here for you. This is the composition. We talked about when you have these compositions, instead of using the composite bubble, if you want to use the parentheses, sometimes it's a little clearer. So here when we did the f of 3, out came the 5 when we looked at the chart. Then we did the g of 5, and out came the 8. So remember, in goes an x, and out comes an f of x, or a g of x, which is really a y. With number 12 on topic 1, I thought this was interesting. I picked this because you're doing a composition, not only on graphically, but you're doing it on the same graph on top of itself. So out came a -2 out of that composition. So let's take a look at the graph here. So this is the graph of f of x, and you want to put find where x is 6 first, which is right here. And you can see out comes a 2. Then they want you to go right back into f with the 2, and out's going to come a -2. So if you just take a glance at that on paper again, you can get rid of that composite bubble, write it as parentheses. It's a lot easier that way. F of 6, when x was 6, y was 2. So we're going to go back in and do f of 2. When x is 2, out comes a -2. So instead of doing it with equations, you're doing it graphically here. Number 13 on topic 1 was a composition. Some of you, if you didn't really read it, might not have figured that out. And some of you saw that they do indeed link together by a common letter. So you have these two equations right here. Sorry about that. We have these two equations right here. And again, the answer was 174. I don't know if I said that. These two equations. So this represents the temperature, and it's in terms of this m, which is moving parts. So they tell me in the body of the question that the moving parts are 4. When I do f of 4, I do 0.3 times 4 squared, right here, and I get my 4.8. So that 4.8 really represents T, temperature. The second equation is I think it's resistance, if I'm not sure. What was it called? Yeah, resistance. So this is resistance, and this resistance equation is in terms of T. So the T I know is the 4.8, and that links in there. So I'm evaluating this at G of 4.8. So you do 150 plus the 5 times the 4.8, and I get 174 as my resistance. So don't get scared by something like this. It has some words. If you really look at it, it wasn't that big of a deal. The last one I saw on topic 1 for compositions was number 14. And either answer, 2x plus 1 quantity squared or 4x squared plus 4x plus 1 would have been acceptable. If it were a part 1, they definitely would have distributed. As a part 2, it's really not necessary. Unless they said express as a trinomial, then you would have been forced to write it out twice and double distribute. Now I call this a composition rule, and I'll tell you why. It's in terms of x. If there were a number here, we pretty much know how to do that. You put the number into G, out comes a Y, you put that Y becomes your X for F, and you get your composition. But no, not with a rule, because a rule is good for any X. Again, this composite bubble throws a lot of you off. So write it like this with parentheses, and it makes a little bit more sense. So really, what is G of X? It's 2x plus 1. So I have to put in 2x plus 1 into f. If this were a 5, I would do 5 squared. If it were 10, I do 10 squared. But it's an f of 2x plus 1. So in this x box right here, I'm going to put the 2x plus 1 right there in that circular box there. Circular box, oxymoron. So now I put that 2x plus 1 there. And again, like I said before, if it didn't say express as a trinomial, I would have left it alone as my part 2 answer. But as a part 1, they will expand it. How do I check this? Very easy. You pretend x is a number. You do a Mach substitution. Remember, Mach substitution is really great for expressions. So if I did like f of g of 3, and I did the composition the long way, and I put a 3 in here, they would be equivalent. If this were a part 1 as a composition rule, you could do the whole thing by Mach substitution. So really embrace the Mach substitution for something like this, specifically as a part 1. So I want to show you one other thing that wasn't on the sheet. You could do more things with functions. Using these two functions here, sticking with the f of x is x squared and your g of x is 2x plus 1. If it said to do f of x plus g of x, you're just really just adding them together. That's f of x, that's g of x, and that's their sum. But if they said to multiply it, you're just going to multiply it. I don't know why I put parentheses around there, but you distribute that x squared, and that's the product. You want to subtract it? Subtract it. This is if they ask. This is x squared, subtracting g of x. Notice I put that in parentheses, got to subtract the whole thing, distribute the -1, and there you go. So this is some function computation, if you will. This also could have been checked with Mach substitution, pretending it's a 3. F of 3 plus g of 3. F of 3 times g of 3. F of 3 minus g of 3, etc. Of course, you'd have to both be 3 because x is x. It doesn't change in that Mach situation.